We have started the stream. Excellent connection. Okay. Okay. So let's get started. Let's get started. If I go here, do you see my screen? We are going to do linear algebra. I have an exam on the 27th of April. Today we are the 23rd, I believe. We're going to look at chapter 3, null space of A, rank and reduced form, complete solution to AX equals B, A being a matrix, X and B being vectors, and then we have independence, base, and dimensions. So we're going to look at how does the independence of vectors create a base and for which dimensions. Then we are going to look at the dimensions of the four main subspaces. A lot to unpack. We have a big list of exercises to do, and we're just gonna jump right in. So here, I'm gonna start here. We are going to log this at 500, 200. Let's log that in. And then let's try this here. Oh, too big. I'm going to go to get. Okay, so we are in section 3.2. Yep, section 3.2. We are going to be looking at null space of A. Let's go ahead and start with the exercises. So we are going to do exercises 9, 19, 21, 23, 26. Okay. Kind of excited. This is my first live stream. So for those who don't know me, I am Marun Reza. I'm learning how to learn. This is a challenge for me, and here I will be displaying how I practice it. This is helping me be more consistent and to be more honest with my work. I will also be listening to your feedback. So thank you for for keeping your attention with me. So let's start with number 9. This is going to be page 142 of the book. So, well, I wrote the book previously, but it's basically Introduction to Linear Algebra by Gilbert Strang. So yeah, let's get started. So here we are being asked to verify whether it's true or false. So this is a true or false exercise. Okay, so first of all, we have, is a square matrix can a square matrix not have free variables? So that's a good question. So we are asked if A is an n by n, if A is n by n, can it have oh, or even it's not even can it have, it's saying that, so this is the proposition, no free variable. Now, when do we have free variables? That's the real question. So this is the proposition P, and this is what we're saying. It's if A is an n by n, then we have no free variable. Okay? Now, to verify this, we need to know the condition to when do we have a free variable. Okay? So from what I learned, we have a free variable when my matrix A mn, doesn't have to be squared, does not have, has that is missing pivots. So let's say we have A, B, C, D. So this is, and these are the pivots. And here we have a 4 by 4 basically. This is a 4 by 4. If any of these variables is equal to 0, then we have a free variable. And as you can see, it's a square matrix, and yet we have a free variable. Now, when we want to disprove something, we can give a counterexample. So let's give a counter example. In French, it's called contre-exemple. Contre-exemple. So let's find one. We want let's take a 3 by 3, 1, 1, 1, 0, 0, 7, 0, 0, 0. This one here, we have two free variables here. Yeah, we have two free variables. This is a 3 by 3, so go to A, which is a 3 by 3. This is squared, yet we have two free variables. So we're going to call them, I believe, x1, x2, something like that. But I need to review my course. But let's say two free variables. So conclusion is false. Okay, great. Let's move on to the next one. So let's go to B. We have, okay, so if A minus 1 exists, so this is our proposition. If A minus 1 exists, this implicates that no free variables. Okay, this is my, so this means that if A is invertible, if A has an inverse, then we have no free variable. So if A minus 1 exists, this implicates that n of A is equal to Z, which is equal to 0. Well, that's true. That's true, and we can prove it through the absurd. So let's say if, so I'm going to call it P2 because it's another proposition. So if P2 is false, if P2 is false, well, this implicates that A let's say A23. Can we have it not squared? Yeah, we can have it not squared. So, yeah, n of A23 is different than Z, and A minus 1, 2, 3 exists. Which is impossible. This is, so this is impossible because we have to have our matrix be squared. It has to be squared. Must. It has to be squared. Therefore, we have that this implicates that P2 is true. Okay. Next, let's go for C. C says that if we have a matrix A, so let's go for B3, what's the proposition? We have a matrix A, n by n, has P pivots smaller or equal to n. So P is number of, oh, I'm gonna call it R because it's basically the rank. We'll see this later, but so let's say R is the number of pivots, So we have R is the number of pivots, and well, for AMN with R is smaller than n, yeah, so this is what they're asking. So if A is a m by n, so an unsquared matrix, then its rank will always be smaller or equal to the number of columns. So as you may know, or may not, this is why I'm gonna try to explain this. I do not guarantee any thing that is correct in what I'm about to say, but let's give you an example with a 3 by 3. For a 3 by 3, we have n columns, so there are n columns. So these are all column vectors, and then we have m lines. Okay, m lines. So basically, as you can see, if we have a full ranked matrix, it has to have the same amount as the number of columns. So we cannot have a rank, which is basically the number. So the rank represents the number of pivot variables. So we cannot have more pivot variables than the number of columns, because you can't have more than that amount, since it's one per column vector. So you can have a lot of column vectors. So we're going to give a few examples here. Let's say you have, in another case, 1, 2, 3, 4, 5, 4. Let's say 4, but you have only 3. So here, m is smaller. Okay, so here, m is smaller. Now, in this case, the maximum amount is still going to be 1, 2, 3, which is smaller than n, which is n is equal to 4, which is because m is smaller than n. Okay, now let's give the other example, which is for m being bigger than n. You gotta read it the vertically, but you get the point. 1, 2, 1, 2, 1, 2, 1, 2. So what's the maximum amount of pivot variables? 2. Yeah, 2. Because then you have to go to the next column vector, whereas we don't have any, and n is clearly equal to 2, so r here is equal to n. I hope this makes it clear. So we're gonna say this is true. So P3 is true. Now, can I give a better, more mathematical, rigorous explanation? Like, let's say I'm in my exam and I have this question: if A is an mn, how do I know how do I prove this rank? I would probably show this. Hmm. Let me think about it. I want to see, is my stream actually working? Are we actually streaming? Let me send something in the chat. Hello, everyone. Not sure. Let's see. I'm gonna end the stream. Gonna end the stream to verify what's up. So stop streaming.